Good morning. In this video, we're going to look at the accent floor tile for the second floor lobby at the Marriott in Daytona. This is the overall insert for the tile stripe that goes through the lobby, and multiple instances of this. But what we're looking at here is essentially two different metallic strips, one here, one over here. The ones that are depicting here are actually aluminum, not stainless steel. It calls for stainless steel. It's a slightly different profile, but we can ignore that. Then we have a 4-inch strip of a darker color here and an 8-inch strip of a lighter color here. The 8-inch tile is 24 inches long and the 4-inch tile is 4 feet long. And what I've done is I put together a few models here to show you the difference of using different size tiles and where the issue comes in on this. So here we have a curve. This is the curve of one of the lines in the lobby, and you can see what's going on here. This is the tile that's specified. So this is a 4-foot tile adjacent to a 2-foot tile. So your 4-inch by 4 foot, your 8-inch by 2 foot, and you can see what's going on. As soon as we get about 4 feet down the curve dies away about 2 inches. And because of that, we only have one grout line where we can take up the gap. So you can see in between the tiles here, this is actually a 1/8-inch grout line, which is specified, which is the same grout line that's used for all the tiles on the second floor. So this is what represents the 1/8-inch grout line, 3 millimeters. And this is the gap that's created on the one side because of that. Even if you try to cut around the curves, it doesn't work. Simply because the curve switches back, and you can see on the second portion of this that you will get a gap that goes both with the radius and perpendicular to the radius. Over here, we've taken those same tiles and cut them much shorter. So instead of one being 4 foot long, we've cut them down to 1 foot each. So the bigger tile would have been 2 feet, the smaller tile would have been 4 feet, but in each instance what we've done, cut it to 12 inches and then staggered the seams so that we don't get that radial effect here. In doing that, you can see what's happened. While the gap isn't quite as large as it is in the first instance, it's still well beyond what would be deemed acceptable. The gaps stagger all the way through, and then the problem reverses itself once the curve goes off in the other direction. So the one way to resolve this is to have more grout gaps that we can take up the variation in the curve with. And what I mean by that is if you use a smaller tile, you'll be able to take up 1 millimeter or so at each one of these tile junctures. So each one of these grout lines will get roughly 1 millimeter or so shift in it. And then when you multiply that over all of the shifts that take place here, you'll actually have something that flows. Now the tile that I used in this instance was a 3/4 by 3 inch. So it's a 4-to-1 tile ratio. You want to keep the length of the tile 4 inches or less. But rather than using a square tile, if you use a rectangular one, it'll give you linear flow down the curve, and it'll actually work in the same manner visually is what the original intent was. So your eye follows down the curve rather than just looking at an insert tile that you can't really judge which direction it's going. So you can see here in the next scene that those gaps as you go around the curve will resolve themselves, and you'll end up with something that's acceptable aesthetically. No matter how acute the curve is, everything up on the second floor will be able to be accommodated by the aspect ratio of this tile, and it'll actually look decent. But unfortunately, given what was specified there in terms of material, it simply won't work. I've talked to the tile supplier, and they're looking into different options of tiles that are available that should serve to meet your aesthetic requirements here.